Hello, welcome to Leetcode Biweekly Contest 146. We are solving problem third. Check if grid can be cut into sections. So in this problem, you are given an integer n representing dimensions of n cross n grid with the origin at the bottom left of the corner. You are also given a 2D integer coordinates rectangles where rectangle I is in the form of start x, start y, end x, and y, representing a rectangle on grid. Each rectangle is defined as start x start y is bottom left corner of the rectangle and x and y the top right corner of the rectangle. Note that the rectangles do not overlap. Your task is to determine if it is possible to make either two horizontal or two vertical cuts on the grid such that each of the three resulting sections formed by the cuts contain at least one rectangle. Every rectangle belongs to exactly one section. Return true if such cuts can be made, otherwise returns false. So first see what the problem says. So it says that we have to make two lines such that, oh, this is not visible. Let me take another color. So blue. So it says that this is one section and this is another section. So we see that since the rectangles are not, every section has its own rectangle. So this is one rectangle in this section. These are the two rectangles in another section and three standalone rectangle in another section. So we can make this horizontal lines given. Okay. Now let's undo this. And here we can't make any either vertical. Let's if I make a vertical line here, it will cut this line which we don't want. This rectangle should not be cut. And similarly, if I can only make one cut over here, because if I make a cut over here, I will have two sections. It will contain three, it will contain two, and if even if I make a line here, it will contain zero rectangle. So every section should contain one uh, rectangle each. So that is set in this problem. So these are the conditions, and we need to tell whether can we make two intersection vertically or horizontally as we want, if yes or no. So that is what they have said. So n means that there is n cross n grid, and these are the coordinates that are given. So this was regarding the first example as we shown, two horizontal lines, and we can segment the rectangles differently. In the second problem, we can make two vertical lines, and you can see that how they are distinguishing from each other. And in third, we cannot make the triangle. We cannot make the segments. So first I'll walk through the code and what the idea is, and then I'll go to the graph and see that why it is working. Okay, so what we're going to do is first we will segment out all the x-axis in one uh, vector of vector and y into another. Why? Because if you see the problem mostly resolves about checking whether how the intervals are changing on a particular x-axis. If you're looking at a rectangle, first you will notice that if we will check for if horizontal cuts can be made, then we will go look all the y coordinates of how the rectangles are changing. And similarly, if you want to make the vertical changes, you will see how the rectangles are behaving, how the intervals of rectangles are plotted on the x-axis. So we will be observing that. So for that, what we'll do is we will take x and y that will be holding the x and y coordinates separately for every rectangle. So we will iterate through rectangle. We will see that the first and the third element is basically concerned with the start x and end x. So that is why they are stored in x vector. And similarly for y, first and last elements are the start y and end y. So that is why we are storing it in y vector of vector. So after that, what we'll do is we will sort our both x and y Rudy arrays that we have. Now what we'll do is first we will iterate over x and we'll see can we make such interval, two intervals basically. If that's the case, we will return there itself true. Otherwise, if we cannot make, we'll check for uh, on the y-axis that whether can we make interval or not. So what we are doing in here is that we are checking that start the iteration, and before start the iteration create two variables. One is overlap. What overlap says is that are there any segments such that which are not overlapping. What I mean to say is that if you see this case, it is on the y-axis. If you notice, it is starting from 0 ending at 2. Next one is starting at 2 ending at 4. Another one is starting at 4 and ending at 5. So there is no overlap between that. Some other triangle is starting from 5 to 3, and that will make it overlap. you see that it is sitting in the segment, it is not going and disturbing the other segment. So that is what we are checking. So for that, overlap is a variable created. Previous is storing the first element. Since we have sorted it, it will be the very first element's end value. So what we'll do is, basically we'll start the iteration. We'll see that the first element that we have vector we are getting, it is the first value, that is start x and start y. So start x is greater than equal to previous value or not. If that's the case, we will increment our overlap by 1. Okay, what it means is that we are out of a segment. Let's see, in this problem, let's see if we have 0 comma 2. In the next iteration, my previous is 2 over here, 0 greater than equal to 2 or not. So it says no, it false, and previous is updated to 2 again, because which was originally the case. It will now go to next problem, next index. It will see that whether 2 is greater than equal to 2 or not. Yes, it is greater than equal to 2, so our overlap will increase by 1. Now previous will get updated by the maximum of previous of the or the second value. Now my previous is 3. It will go here. It will see that whether the first element is greater than equal to previous or not. No, it is not. Now it will get updated with the maximum of previous or this element's second value. Now you go to the next index, you will see that whether 4 is greater than equal to 4 or not. Yes, that's the case. So overlap will increase by 1. So overlap value is now 2. Now what 2 means? 2 means that I can make 2 cuts, and if 2 cuts are made, so more than one cut is required, so there can be many other cuts. So if overlap exceeds the value of 1, because we are concerned with making 2 lines, so if 2 lines are possible, we'll simply 2 lines means greater than equal to 1. So there can be 4 or 5, but we are concerned with, we can have to make only 2. So if it's greater than 1, we'll simply return true. Otherwise what we'll do is, we'll again update overlap 0 and previous to now y of 0 comma 1. So now we have iterated over the x-axis. Now we'll go on the y-axis. For x-axis we tried for the vertical lines, and now for y-axis we'll see the horizontal lines. Similarly, we'll check that how we approach the algorithm that we just discussed for the overlaps. So that is being done accordingly. Previous is being updated, overlap is being checked. Simply when we come out of it, we'll see that overlap is greater than 1. If that's the case, we'll return true, otherwise we'll return false. So that is the basically what I'm doing, and this is working accepted code. Now let's jump simply here and see, this is the first example and this is the third example. So we'll see, try to visualize it. So these are we have marked or the shades that I've given. So those are the rectangles. Now what I have done is, I have segregated out x and y axis, and if you see, I have sorted it also, that I have started from 0 to 2. So this was regarding this rectangle 0 to 2, it is being noted. For 2 to 3, this is regarding this rectangle 2 to 3. Then 2 to 4 is this index, and then 4 to 5 for this rectangle. Similarly, if you go and check for how the x coordinates are varying, so 0 to 2 is this for rectangle 0 to 2, 0 to 4 is for this rectangle 0 to 4. Then we are going for 1 to 5, that is also being noted, and from 3 to 5, so that is 3 to 5. So first, according to algorithm, we are iterating over this. So initially we started previous with 2 value, 0 is obviously not greater than uh, 2, so we'll jump here. We'll see that 0 is greater than equal to 2 or not. No, it is not. After that, we'll update maximum of 2 or 4, so that previously we updated to 4. We'll come here, we'll see if 1 is greater than equal to 4 or not. No, it is not. Then previous will update it to 5. We'll check if 3 is greater than equal to 5 or not. No, it is not. So for this value, overlap will be 0. So in this problem here, overlap will be 0 and this condition will not be satisfied. Now we will go and iterate our y axis for horizontal segments. Now we'll go to y axis. Previous is 2, 0 greater than equal to 2. No, it is not. Updating previous to 2 itself. 2 is greater than equal to 2. Yes, overlap updated by 1. Updating previous to 3. 2 greater than equal to 3. No, previous being updated to 4. And checking again, 4 is greater than equal to 4 or not. Yes, overlap updated to 2. That's all. We got overlap to 2. Here we'll check overlap greater than 1. Yes, it is. Return true. So our answer for example is true. Now for example third, our answer is false. Let's see why it is false. So this is our example number 3. We have noted it down. x and y coordinates. So let's see how x coordinates are varying. So for this triangle rectangle, it is 0 to 2, noted 0 to 2. Now 1 to 3, 1 to 3, then 2 to 3 is this for this rectangle, 2 to 3, then 3 to 4, and then 3 to 4. Again there were 2 3 to 4, so 3 comma 4. Okay, now let's check. Previous is 2, 0 greater than equal to 2, no. Previous still being 2, 1 greater than equal to 2, no. But now previous will get equal to 3, not 2 greater than equal to 3, no, that's not the case. Previous will remain 3 itself. Now 3 greater than equal to 3, yes. So updating by answer by 1. So what it means that we can make a line, this segregation that we can make. Okay, so overlap is 1. Updating previous to 4, 3 greater than equal to 4, no. So overlap remains 1. So only one line could be made. That means if overlap is 1. Now what we'll do is we'll go and check for our y-axis. Now for y-axis, let's see how it is done for this rectangle, 0 to 2. Similarly for this rectangle, 0 to 2. So 2 0 to 2s are there. Then 2 to 4, 2 to 4, 2 to 4 for 3. So 2 to 4, 2 to 4. Now previous is 2, 0 greater than equal to 2, no. 0 greater than equal to 2, no, that's not the case. Again 2 greater than equal to 2, yes. So overlap increases by 1. That means this one line can be made. Previous updated to 4, yes. Now 2 greater than equal to 4, no, that's not the case. For previous remain 4 itself. 2 greater than equal to 4, no, previous remain 4 itself. So here overlap is 1. So as per our condition, if overlap is less than equal to 1, no, we cannot return true. So finally it will land up and return false. So yeah, that was the all our idea for this problem. If you have any query, do comment it out. If you like the video, hit the like button and do subscribe for more daily content, guys. Thank you.